Welcome back, everybody. We're here now to talk about SIP gateways. I've actually decided to combine the SIP gateway and Cube lecture as well, so that way it's kind of a nice transition anyway, we can kind of go right into it. So SIP gateways are much like H.323 gateways in that they are peer-to-peer. They don't register with Communications Manager whatsoever. It's just a way that you can get calls from Communications Manager to the gateway. Now, definitely different from MGCP, because MGCP is the client-server gateway architecture. Once again, ISDN is going to be terminated directly on the gateway itself, directly on the router. So nothing really different here from H.223. We've got to do all the same configuration commands that we would normally do to set up the PSTN connectivity. We've got to do our controller configuration, our ISDN configuration, all the things like that, dial peer configuration, any digit manipulation we want to do before we send it to Communications Manager. So that's all going to be the SIP gateway. Then we'll talk about Cube, which is going to be kind of like the central point of focus for call routing in the network, or it can be set up that way if you want it to be. So let's move over to the actual slides here and talk about the SIP gateways. First of all, once again, peer-to-peer protocol. It's not going to register with CUCM. You're just going to configure a SIP trunk actually in CUCM to connect to the gateway. Remember, we actually had gateway configuration opportunities here with H.323 and MGCP under the device and gateway section. Now, under the device trunk section is where we're going to configure a SIP gateway. So if we want calls to go out via SIP, we've got to configure a SIP trunk in Communications Manager, and then on the iOS side, we've got to configure the SIP gateway to accept those calls. So device trunk is where that's done. We have to configure the voice service, which is the global voice configuration, and or the dial peer binding commands to make sure that that protocol is going to be running on one of those interfaces. Remember, we talked about this for phone registration as well. We need to have the global voice configuration set up to accept registration requests. And the same thing here, we've got to say if a SIP request is coming into the router, we want it to use this address. Or if a request is going out of the router, we want it to use this address. So under voice service VoIP, we're going to say SIP, which is entering the global SIP configuration there under voice service VoIP. Then we're going to say bind control or media, or bind all, whichever you want to use, and we're going to say source interface, whatever interface you want to use. This one's a loopback address, so we're going to use source interface loopback 0. So that is going to be the source address as we connect to other devices in the network and as we receive requests from other devices in the network. So that's going to be the interface that it's running on. We can also do this now at a dial peer level. We can bind the source and media, or the control and media addresses, to a specific source address on the dial peer level. So maybe if you have a different dial peer coming in from a couple different devices, maybe you want to have different sources interfaces, or maybe different interface bindings on both of those dial peers, depending on what you want to accomplish there. So that allows you the opportunity to get pretty granular with that configuration. So once again, this is a distributed dial plan where CUCM is going to have the route patterns, and also iOS is going to have dial peers in order to route that call successfully. So here's the example configuration. Once again, very, very similar, if not the same in some cases here, to H.223 and even MGCP. We've got to do our card type command. Once again, this is T1 here. Network clock participate. We've got to do our ISDN switch type. Nothing different here from H.223 and MGCP. All that's the same. Once again, we've got to do our controller config, which is PRI group time slots 1 through 3 in this case. It's using 3 time slots. You can also do 1 through 24, whatever you happen to be. We do not have the service MGCP keyword on the end of this, so we're not using MGCP for this communication. Just going to be using ISDN. The actual rest of the configuration for SIP now is going to be, like we mentioned before, under the global voice configuration. We've got the SIP global configuration. We're binding the control and media source interfaces to loopback 0. So loopback 0 is going to be handling all of our SIP communication from now on based on this global configuration that we have. Once again, I mentioned before that we had under the serial interface the serial 000:23 interface that was auto-generated when we did our PRI group configuration. We've got to put our ISDN outgoing display IE there so it actually has the ability to send caller ID as it goes out of that interface. Then finally, we need to have a dial peer in order to accept calls from Communications Manager and also send calls out to Communications Manager. So we have dial peer voice 2000 VoIP. We have 312-333-2 ... So that's expecting then a 10-digit number to be sent to Communications Manager here. So at this point, we can assume then that a number coming in from the PSTN will come in as a 10-digit number and then go right out this dial peer in order to go to Communications Manager. So we're saying destination pattern 312-333-2 ... and then $ to end that string. We're saying session protocol SIP v2. So remember, this is going to be a SIP dial peer. We actually have to define that because the default session protocol that we're going to have is session protocol Cisco, which would be H.323. Next here, we're going to define our session target, which is going to be 10.10.23.11. It's going to be our Site B publisher in this case. This is a Site B gateway, it looks like. And then we're going to define a DTMF relay method here. We've got two methods defined, so that's going to allow RTP, NTE, as well as SIP notify as valid DTMF relay methods to use on this dial peer. And then once again, we've actually hard-coded a codec here, G711 MULAW. So we're saying it has to use this codec. So if the other side, if the CUCM server does not allow the use of this codec, you're going to get a fast busy, and you'll actually need a transcoder to complete this call, because a transcoder would translate between two different, or transcode essentially between two different codecs there. But if the other side is running G711 or allows the running of G711 to happen, then this is going to be completely fine. Once again, we're turning VAD off here because VAD is bad, right? So, SIP, verification, and debug. Some of these commands are the very same as you would see in H.223. Show call active voice brief, same thing. Show voice call status as well. Show dial peer voice summary, same thing that we saw in H.223. Show dial plan number is a very good command to see what dial peers you're actually using. And test voice translation rule. Of course, that's going to test the translation rules you have configured in iOS, provided that you give an input number that would match one of those rules. We have debug VoIP dial peer because, once again, there's just iOS dial peers we're using here. Nothing strange, nothing crazy. Debug voice translation. This is to see whether translation rules are actually getting applied and how they are being applied, in fact. Debug ISDN Q931 because that's going to be our ISDN debug, so we can see calls coming in, calls going out of the PSTN. ISDN Q921, remember we talked about that as the layer 2, so we can verify that we actually have, first of all, layer 2 connectivity with ISDN in the first place. And then the last one is the debug to end all debugs as far as the CCIE collaboration lab is concerned. It is the debug CC SIP messages command. This is going to be probably the best debug that you're going to find in the lab to use because there's just so much SIP to use in this configuration here. We have SIP on Cube, we have SIP gateways, we have SIP trunks connecting to iOS gateways. This is, as long as you're involving an iOS device, this is the best SIP debug command to use. So debug CC SIP messages. Very easy to use, very easy to see what's happening in that communication. We can actually take a look at that as well. So that brings us to the Cube overview. But before I do that, I want to actually move over to Communications Manager and show you how this might be connected here. Now, Cube is going to be the same thing as a SIP gateway. Essentially, it's just a regular gateway, almost. There's just a couple little differences here, but the way that you would connect to it from Communications Manager is the exact same. We've got a Cube SIP trunk here, and just imagine this could be, a PSTN SIP trunk. In fact, I mean, it could connect to a SIP gateway that's only handling PSTN functionality for us. It wouldn't look any different. And we've got a device name, we've got a device pool, of course, that is going to allow us to have specific settings in there, like region settings or specific settings associated with that, location, that type of thing, media resource group list, everything else you can find in there. And as we scroll through, see, obviously we have the significant digits here. We can accept, all significant digits, all digits, or we can change that to 4 or 5 or whatever our dial plan length is. Also, a calling search space would be assigned there. And as we scroll through, we can see that this is actually pointing towards an IP address, and that would be the IP address that's bound to the interface or to the SIP process on the SIP gateway or Cube router. In this case, it's actually 10.10.11.1, which is the gigabit 00.11 interface on R1. And as I scroll through here, you can see we've got a SIP trunk security profile, which is just default non-secure SIP trunk profile, and a standard SIP profile. So that's all we really got to do there. There's nothing special, nothing crazy about this configuration. But this is just set up for call routing, of course. So we can now accept inbound calls in. And you know, we could decide, like we did in the H323 gateway example, we could decide to do digit manipulation on the gateway itself, strip that number down to 4 digits, and then send it out to Communications Manager. Or we can do like we did in this example here, where we have a 10-digit number being sent to Communications Manager. Well, in that case, you've got to perform some type of digit manipulation. Maybe that would be in the significant digits field. Maybe we would set that to 4. Maybe that's a way we could deal with that. Or maybe we could set that to all and just apply a translation pattern as it comes into Communications Manager. So a couple different options there, of course, for how you would deal with that. So moving along now to Cube. Let me go back to the actual slides here. So Cube, like I mentioned, is really no different than a gateway. Don't let the term scare you. It's basically just going to be a centralized management point for your dial plan is what it's supposed to be. And it can run H323 and SIP and talk between those two protocols, of course, and allow your media to flow through the cube or flow around the cube. It's basically just another iOS routing device, if you want to look at it that way. And it's not much more than that. So there are a few little differences here, though. So first of all, it terminates and originates signals and media streams. So when you think about that, if I'm communicating with Cube via SIP, I want to also, maybe send. Well, I want to send first of all a SIP signal to communicate with that, and then maybe it has to go to a dial peer that's an H323 dial peer. Well, now it's got to interwork between those two signaling methods. So if I send a SIP communication to the Cube is then got to be intelligent enough to know how to translate between SIP and H323 to do that. And if it's going from SIP to SIP, you have to be able to do that as well. H323 to SIP if we got a call coming in from there and going out through SIP, and also SIP to H323. So when you think about this kind of looks like those allow connections commands that you would have to put in your global voice configuration. And remember what I said is that we would have to put those in. We don't have to, but it's a good idea to put them in on every single router right off the bat. We can say allow connections SIP to SIP, SIP to H323, H323 to SIP, and H323 to H323. So it's a good idea maybe to just blanket statement, put all those in right off the bat. That way you don't have to ever worry about it. Because if those commands aren't in there, you won't be able to interwork between those two signaling protocols. So you got to have those commands in there in order to do that. So it's going to terminate and originate signals and media streams for those protocols. It's going to act as, of course, it's going to act as a border between these two signaling methods. So if you really think about it, it is in fact a border element. I mean, it's going to terminate the signal. So let's look at a quick diagram of this, how this would actually look here. So if I have a cube in the center here, and I have a communications manager server, and another CUCM server. Let's say that this is H.323. Let's say that this one's SIP. So the cube is going to act as kind of that border between those two signaling methods, right? And even if this was SIP over here, it would still act as a border, right? So let's say that the request comes out from SIP. You got a SIP invite coming in here. And then now Cube is going to have to say, well, you know what? This call is supposed to go over an H323 trunk. And this is an H323 dial peer where it's terminating. So I have to regenerate that signal out to this CUCM using H323. So now it's got to translate between those two signaling methods, right? So let's say then, for example, if this was not H323 anymore, this is SIP. Well, the same thing needs to happen. It's still going to be the middleman for your communication. It's going to send out that invite, that SIP invite, just like it would before. You're not letting these two endpoints communicate with each other directly. You have to communicate through the cube. So cube is terminating that signaling. It's always going to terminate the signaling as well. And you can decide to have your media, after the signaling is done, you can have your media flow through the cube, or you can have it flow around the cube. So a couple different options there for you, obviously. So this is going to terminate that signaling path, is really what that comes down to. So signal interworking, we already talked about that a little bit, if we're going to go from H.223 to SIP or vice versa. Media interworking for DTMF, fax, modem, codec transcoding, that type of thing. If we have some differing media types or different media types that come into the cube, we have the ability to negotiate between those or try to resolve differences in those media types. Codec transcoding, you actually register a codec or a transcoder directly to the cube at this point now. And you used to have a telephony service or a call manager fallback process in order to, no, I think it was only telephony service to actually register a media resource, like a transcoder, to the router that way. And now you can just do that directly from the cube configuration. So that's kind of nice as well. And lastly, address and port translations. It kind of goes without saying, I guess, if this is going to be a terminating and originating device, it can use whatever port number or address it wants to use when it communicates with the other device. I mean, so this CUCM could be communicating with 10.10.11.1, and maybe this part of the cube would be sending out the invite from 10.10.1.1. So completely different IP addresses, obviously. So this CUCM over here thinks it's communicating, well, is communicating. It is communicating with 10.10.1.1. This CUCM is communicating with 10.10.11.1, but it has no concept of, this CUCM or this CUCM. It has no idea that even exists. It just knows that cube knows how to get to where it needs to get, essentially. So it's address hiding. It's hiding the actual ports. It's creating that border between two networks is what it comes down to. So like I mentioned before, we have a couple different deployment models here. We have the media flow through option, which is going to have both your signaling and media flow through the gateway or cube, and it is recommended for PSTN termination. So obviously cube is a good device to use for the PSTN because you can have centralized SIP trunking done here and have everything sent to the cube essentially, and have it go out these big hefty SIP trunks to handle a lot of calls. So if we wanted to have it in a PSTN scenario, once again we have our cube here in the middle, and we have our PSTN cloud, and then that's connected, maybe via a SIP trunk on its own. So that's obviously a VoIP dial up here that would control that. Then we have a CUCM device over here that would be connected either via SIP or H.223. Obviously, if you want to make it easy on yourself, try to keep the same protocol so you don't have to have any worry about the difference in protocol causing features not to work correctly or something like that. If you have the opportunity, always use SIP to SIP. Save yourself some trouble. So CUCM to cube here is using a SIP trunk, of course, and then cube to the PSTN, we're using that SIP trunk as well. So devices on the CUCM server have no idea about these devices on the PSTN. No idea about the IP address at all, unless we're using media flow around. But if we're using media flow through, that means that we're actually going to have that cube terminate the signaling and the media. So if we say the signaling from the phone is the blue line, and the media is the green line, that cube is actually terminating both of those signals. And then same thing for the PSTN here. It's going to regenerate that media signal and go over the PSTN. And the blue line would be, the actual signaling that's going through the PSTN to make that call happen. But those are two completely separate streams communicating with the cube directly at that point. So that's media flow through, the green line being the media here. Now, if I wanted to configure media flow around, where perhaps instead I had a CUCM over here that was on my network, and I still wanted to use cube to route through to this CUCM, maybe this is another SIP trunk here, I could say that the cube has a dial here that points out to this CUCM, and I want to use media flow around for that communication. So the signaling still would be, from this phone into the cube, signaling would go right back out over that SIP trunk to the other CUCM. But now, instead of that signaling coming through the cube from the phone, and back out to the other CUCM, it would instead go directly from this phone to this phone down here. So now we have media flowing around the cube, and it would go from endpoint to endpoint just as it normally would in any other scenario. So we're not making the media hairpin essentially through the network. We're making the signaling do that so it can actually set up the call, but the media is actually going to go from endpoint to endpoint. So that's maybe what you would want to use in an enterprise scenario. And that's what I have here in the slides as well, is the signaling and media flows through the gateway. It's recommended for PSTN termination here. And then when the media flow around is used, it's recommended for enterprise networks because you know about all the other endpoints. You theoretically will have probably secure access to those endpoints anyway somehow. You're behind some kind of firewall or network protection or something. So the media will flow between endpoints in that case. So the cube overview, right? Talking about some of the different things that we have here in Cube. It's basically the same basic setup that you're going to see in H.223 or SIP. And it's best to configure, like I mentioned already before, the SIP trunking if possible. So you want to use SIP wherever possible. Now, not SIP and H.223 combination. If you're going to use H.223, use H.223 everywhere. so you don't have to interwork between the two. So it's better to use SIP at this point. It's a lot easier to troubleshoot. So configuring voice service VoIP to bind to an interface, preferably the loopback one. We already talked about that one a little bit with the SIP gateways, right? So with the gateway, we have the opportunity to do that globally, or we can do that on the dial peer level. So the command here, mode border element, is very important as well. It allows you to use those media commands when you enter that command. But when you use the mode border element command, you actually have to restart your router in order to let that take effect. So my advice then is, if you know where the cube exists early in your lab as you're reading through it, maybe enter that command in there and do a quick reboot of the router while you're reading through the lab or while you're doing something else. Because you don't want to be waiting on the router to reboot as you're going through the lab. You just don't have time to wait, you know. So it's better to just enter that command, save it, do a quick reboot, and that's it. Next here, obviously it says it enables the media command under voice service VoIP, so media flow through, media flow around. And then to actually get to cube, we already talked about this a little bit too, but that's going to be done through device trunk. Remember, we're not creating a SIP gateway, we're creating a SIP trunk to get to the gateway that we're going to be using on the cube here. Now, another cool thing about the cube is that you can customize the SIP messaging if you really want to. And you can do that using a SIP profile. The SIP profiles basically allow you to match a specific string somewhere in the SIP messaging and then modify that string as it goes out to the other dial peers or goes out to the other system in the SIP messaging stream there. So you can see here, voice class SIP profiles 20, we've said we want to modify the request invite. So we're modifying an invite message here, or we want to change specifically the SDP header. So remember, SDP from before is the session description protocol, or the media negotiation portion of the SIP messaging. So in the invite, we're modifying the SDP header. Extra credit for those who know why we'd be modifying an SDP header in the invite, or what that means if there's an SDP header in the invite. That actually means that we're utilizing fast start here. Or not fast start, early offer. I don't get the extra credit because I got that one wrong. Fast start would be H.323. Early offer would be SIP. So we're using early offer, meaning we're putting the SDP in the actual invite, the first invite there. So that means if we're modifying the SDP header in the invite, it must be an early offer scenario. So we're changing the video bandwidth info, and we're just saying we're going to add this line, B equals AS 4000. So we're going to modify the bandwidth info to include 4000 K of audio, or video, excuse me. So next here, we can apply that globally, or we can also do that under a dial peer. So we can do SIP profiles 20 under the global configuration, but that means now that every single piece of communication that goes out of this cube, as long as it's a piece of SIP communication, is going to have this added to any SDP header of an invite that's sent out. So be careful with that one. If you make sure that that's really what you want to do. It's more common to probably use this on a dial peer level, because then you can get pretty granular with where that configuration is going to happen and what result of that configuration is going to be. So dial peer voice 20 was going to say voice class SIP profiles 20. So we're saying we want to assign that SIP profile to the dial peer directly, so any communication going out of that dial peer is going to apply this SIP profile here. So very powerful tool there, and we can actually look real quick at that and see the different options that we have here. So let me jump on, I believe this one has the cube on it. All right, so we can see here mode border element here. So this is our cube device. Let's see if we do our voice class SIP-profile. And we would just give that a number. So we'll give that tag 20, why not? And you can see right here, you can either do a request or a response. So remember in ours, if I go back to the presentation, we did a request here. So that this is a request that's being sent out, so an invite. I can do a request and question mark, and you can see you can modify any one of these messages here. So super powerful here. So let's do an invite. Let's now see what we would do here. We would do SIP header, STP header, peer header. So let's try a SIP header then. And you can see all the different headers that are available to you to modify. And probably a good idea then is to look at a debug and see maybe what header you actually do want to modify, or what header you're interested in modifying, and then look at the question mark here and see what you can see in terms of where you'd want to change some things. So definitely very powerful. Let's say that we want to do user agent. Type in user agent, and we can now add, copy, modify, or remove. So modify, then we're obviously, if we're going to modify something, we have to match something to modify, right? Add, we're just basically adding to that user agent field what's already there. Copying, we can copy that as well. We can also remove the header completely if we want to. So a lot of different options there for us to choose. And then once again, as I go back to the presentation, you can see that that can be applied globally or at the dial peer level. So SIP profile is very powerful, very cool thing to work with there. So here is the example configuration. We already looked at this a little bit, but first of all, global voice configuration. I didn't mention this command yet, but this is no IP address, trusted authenticate. Now, by default, and I think it was iOS 15 started this, IP address trusted authenticate is enabled by default, meaning it has to validate the addresses that come into the router, as valid or not, as allowed to communicate or not allowed to communicate with the router. And that's done. You can make a list of different IP addresses that are allowed. It can take that list from session target commands. But if you get an address that comes in your router that's not in that list, it's going to deny the call. It's not going to let that call work, and you'll be pulling your hair out trying to figure this out. So the best practice for the lab specifically, although this is probably a good thing to enable in a production environment, the best practice for the lab is just simply to turn it off and not deal with it. Now, there may be a scenario where they say, make sure that you use the trusted authentication mechanism by default enabled in the router. In that case, you'd have to kind of deal with that and see how you'd get around with that. And you just basically add the host to the list of acceptable communication partners with the router. But we'd want to turn this feature off by default, because that way that doesn't limit you in any way when you're doing the configuration. So we've got to turn that off to turn off that toll fraud prevention feature, is what that technically is. We've got to put our mode border element command on, and that's going to enable the use of this router as a cube, as a Cisco Unified Border element. We would then reboot the router. Remember, we have to do that. And then there's all these allow connections configurations in here. Allow connections H to H, H to S, S to H, and S to S. So just go ahead and select all, copy those right into other routers, as well as this no IP address trusted authenticate command as well. So you can see here also we have bind control source, bind media source, and we're saying gig 00.11. So those specific interfaces are going to terminate the SIP process for both signaling and media as calls come into the router and go out from the router. Next here we see, let me pass over this one real quick, but we have SIP-profiles 1, and so you can't see it here in the configuration. Let's see if I have it on the next slide. I do. So we'll save that for later too. But we also have here voice class codec 1 and codec preference 1 transparent. It's like, okay, what's that? What's transparent mean? Well, basically what this is going to do for us is allow the endpoints that are communicating through Cube to negotiate their audio codecs independent of whatever the Cube says. So that way you don't have to negotiate with each separate dial peer. You can allow, the phones themselves to say, hey, I support G729. Oh, I do too, and then you're good. So basically, this codec transparent is going to allow those phone endpoints to communicate with each other freely, or communicate with the codec negotiation freely. Now, coming back up here to this pass-through content SDP. Now, this is kind of the same concept as the codec transparent, but a little bit different, because this is going to be used for video calls. When video calls come through the Cube, you have to negotiate a video call with the dial peer, or you can do a video negotiation with the other endpoints directly. So basically, this is kind of like enabling a codec transparent for your video. You can say pass-through content SDP, which remember is session description protocol. So all the content within that SDP, we're going to pass through the Cube as if the Cube's not going to touch it whatsoever. It's just going to take whatever it gets in and pass it out directly. So it's going to do that so it doesn't interfere with the communication and screw that communication up at all. If you don't have this command in there, you have to physically negotiate the communication on the dial peer itself. So you need to make sure that the dial peer is able to negotiate that communication. And we'll show you through a couple different lectures actually how to do that. So pass-through content SDP is a global configuration command that's going to allow the transparent passing of those SDP settings there, or SDP messages, I mean. So we also have this SIP profiles 1 command globally, and so let's look and see what that does. Next slide here. So voice class SIP profiles, we're saying request invite, SIP header, so the SIP header itself, and we're going to take this remote party ID field and modify something that matches HQ phone 2. So if I ever see in the remote party ID field HQ phone 2, I'd like to replace that with SIP profile HQP2. So that means if you look at this, we're really modifying the caller ID as it goes out. So remember, as you look at the debug on this, it's not going to actually show you the caller ID coming in. I mean, well, it'll show you the caller ID coming in, unchanged. So you might say, wait a minute, I thought I have this enabled globally. I have this coming into the router. It should be changed as it comes into the router. Well, it's not necessarily true, because you really can't change what you've received. I mean, this is what you're receiving. There's no point in changing it until you send it out. So as you send the call out to another dial peer that uses the SIP protocol, it's going to take whatever's in that remote party ID field, if it's HQP2 or HQ phone 2 in this case, and replace that with SIP profile HQP2. We're also going to do that for the re-invite and for any 200 OK messages that come across. So if this is going to be, the other party calling you, essentially, like you want to be able to respond 200 OK with the correct remote party ID. So, and then lastly here we see a dial peer. We've got dial peer voice 51001. We're saying preference 1. So that means that's a higher preference. And if there's a dial peer without a preference command and the same destination pattern, then the preference 0 will be higher than that one. So let's see what's next after that. We've got destination pattern 51 ... session protocol SIP. Of course, we're saying SIP v2. And now session target 10.10.13.12. This is going to be the subscriber, the HQ subscriber here. We're also doing this voice class codec 1. And remember, if we go back a slide, that was our codec preference 1 transparent. So we're saying a transparent audio codec, meaning the endpoints should negotiate that codec freely. And then lastly, we're turning VAT off there. If I go to the next slide, see a couple different dial peers here. Now, dial peer 51002 can fit this on the same page here, but you can see that has preference 2. If I go back here, preference 1. So that means it's going to prefer preference 1. Remember I mentioned earlier, I'd like to have that statically configured in there so I can see, what the preference actually is, rather than assuming it's preference 0 or forgetting it, in a rush. So preference 2 here, that means it's going to be chosen second. And this has got the same destination pattern, 51 ... Same session protocol, and just a different target. We're pointing towards the pub here. And voice class codec 1, once again, that's going to be transparent. And we see here, this one is going to be 52001, destination pattern 52 ... Now we're pointing at the Site B server. So that's also going to have a codec transparent here as well. And then we've gone ahead and broken out the dial peers into different incoming dial peers. And we'll talk about the dial peer stuff in a little bit in one of the next lectures coming up. But there, the reason why we do this is to avoid using dial peer 0. We don't want to use dial peer 0. We want to have our own settings applied, our own specific settings applied. So that's why we did that here. We have an incoming called number, 51 ... So that means any call that comes in the router that has called that number should be applied these settings. Voice class codec 1, that's transparent, and we're turning VAD off on both of these dial peers. So let's look at what this actually looks like. If we draw this out, that might help to see what this is created here. So we've got the cube device in the middle here, and we've got our HQ cluster, we've got our Site B cluster, and that's basically it, right? So let's go back and look at the config here. We've got dial peer voice 51001. Okay, so 51 ... is going to point out to 10.10.13.12. Let's go ahead and draw this other one here. So this would be the HQ sub and HQ pub here. So I have a dial peer pointing at 51 ... out to the HQ sub, right? And I've got 10.10.13.12, so 13.12 here. Also voice class codec 1, so that's transparent negotiation of the codec. Also, if I go back to the presentation, we've got the next dial peer, preference 2, 51 ... Same thing, it's just pointing to a different address. So 51 ... and that's pointing to 13.11. So that means that this one was preferred here, and this one was the backup. So this one was backup. All right, so next, we look at the next dial peer, and that was 52001. It's destination pattern 52 ... 52 ... and that's pointing to 23.11. So that's 23.11, not 10.11. And that goes to our Site B call manager server. And that also has voice class codec 1. So if there are any phones that are registered to those servers, we can call between those servers using those patterns. And of course, remember this is a peer-to-peer protocol. We can't just have those patterns and then now we can call. We've got to create patterns on Communications Manager to get there. So we might have to create a pattern if we're on HQ to 52 ... so we can get to Site B, right? So in addition, I forgot to draw the other dial peers here. We have dial peer voice 1000 and 2000. So that's going to be your incoming called number. So as numbers come into Cube, and let me draw this as not coming from a specific device here. As numbers come into Cube, wherever they're coming from, if that called number is 51 ... then it's going to be applying these settings, voice class codec 1 and no VAD. So transparent and no VAD. Similarly, we've got 52 ... coming in, and that can be from anywhere in the router, not just from HQ. 52 ... That comes in, of course, transparent and no VAD. So now we've got to create those route patterns on HQ and Site B in order to accommodate this communication. And we'll talk about how to do that in the call routing section, of course. But once you make this call, let's say that I'm at HQ from this phone here, and this is 1001, and I want to dial this phone over here, which is 2002. All right, so I make the call, and I actually do have these 5s in front of it, right, on all these route pattern or all these dial peers. So I need to make sure that I accommodate that. I could either have a CUCM route pattern that just says, you know what, I want to use 4-digit dialing, so I could have 2XXX. But then I need to add the 5 on so it could hit that cube correctly, because I've defined my cube dial peers as having 5 in front of them. So I could do that, or I could just say, you know what, instead of having 4-digit dialing. I'm okay with having 5-digit dialing. That's completely fine. So in that case, though, since this number is 2002, I need to have some form of digit manipulation on the cube, maybe, before it sends out to site B, or as it comes in from the cube, I need to have some type of digit manipulation on call manager to accommodate for that 5 that's coming in. So that could be the significant digit setting on your trunk, or that could be a translation pattern or something like that. We'll talk about all those things in the call routing section. Just a little sneak preview there. So of course, 52XXX, that comes into cube. That's going to be going to cube, right? So we have to match an inbound dial pair on that. So since we had the incoming called number 52 ... we're going to be matching this incoming dial pair, which corresponded to dial pair voice 2000. So dial pair 2000 there. Now as it goes out, we have to use the other dial pair, which is going to be dial pair voice 52001 VoIP. And that's going to have a destination pattern of 52 ... So then we're going to be matching this pattern here, and then that call goes from, use a different color here, goes from 1001 from the sub through the cube, through the correct, you know what, let me do this, through the sub, through the correct dial pair, and then through that dial pair as well to get to the other phone, right? And then site B, of course, is going to know where to get to that phone based on the routing that you've done over there. So once again, by default, the media is going to be flowing through the cube. So the media is going to take that same path through the dial pair there. If you wanted your media to flow around, it would be endpoint to endpoint at that point. So that is how the cube is going to work there in this configuration example. So verification and debug now. So we have basically the same as H223 and SIP verification debug. We already talked about how to verify that. But the biggest debug command that you can use here in all cases is going to be debug CC SIP messages. That is going to show you every SIP message that comes in the router related to call routing, and it's going to help you figure out what's actually happening with the calls there. H223, most useful would be debug VoIP dial pair. If you really have to use it, H225 ASN1. Not a very good debug to go through and try to figure it out because it's very cryptic and hard to understand. But debug CC SIP messages is very useful for SIP communication there. So that's going to conclude our SIP gateway and cube lecture there. And of course, we'll talk about call routing coming up in the next section here. And we'll talk about more about SIP and more about cube and how we would want to handle different scenarios and routing. Call routing is definitely going to be a very heavy topic in the lab and something that we should be adequately prepared for. So we're going to talk about call routing in the next section. So thanks for watching this video, and we will see you in the next one.